Hello everyone, I am Meet Leru. I am pursuing my MTech degree in cybersecurity from Marwadi University. Today I will talk about data consistency. It is basically guided by Dr. Ajay Kumar sir, Associate Professor in Marwadi University. So let's take a few notes on data consistency. So basically what is data consistency? Data consistency assures that there is a clarity in a calculation of variable across the whole data set. It is a particularly the interest as a data is aggregated from the several sources. Inconsistency in the meaning of the data between data source can result in inappropriate and accurate data set. So consistency or correctness in database system refers to the required that any given database transaction must change affected data only in allowed ways. So any data returned to the database must be valid according to the all defined rules, including their constraint, cascades, triggers, and any combination thereof. So now we will see why data consistency is important nowadays. So first is the data consistency may be the gap between a big business achievement or a huge disaster. There will be only two chances. Either it will give you a big achievement or it will give you a huge disaster. So data is the basic for a good strategy planning, and inaccurate data can result in the minisprong business plan. So especially when the aggregate data from a various internal or external source, it is important for business to ensure data accuracy so that they can be confident and effective in making business decisions. So that's how data consistency is important in daily business life. So now we will see types and level of data consistency. Basically, there are two types of data consistency. First one is the strong consistency and another one is the weak consistency. We will see the details of strong and weak consistency later on. So now there are five levels of data consistency. First one is a sequential consistency. Second one is the strict consistency. Third one is the atomic consistency, or as we can say linear consistency. Next one is the casual consistency, and last one is the eventual consistency. We will see how types and levels of data consistency in detail in next slides. So what is strong consistency? So it simply means that the data must be strongly consistent at all time. So as all the server nodes across the world should contain the same value as an entity and a point in a time. So, and the only way to implement this behavior by locking down the nodes when the being updated. Strong consistency is one of the consistency model that is used in the domain of a concurrent programming, like in distributed share memory and distributed transaction. The protocol is said to support strong consistency if all access are seen by an parallel process or nodes or processor, etc. So, the current state of the database follows a universally and mutually accepted the sequence of the change of the state. So, strict consistency, atomic consistency, and sequential consistency are stronger level of the consistency. So, in this, end user unaware about the replications of the given database. So, the user has a view of the database as there exists only one copy of the database that continuously reflects each of the state transaction in forward direction along with the operation. So now we will see what is the weak consistency. Weak consistency, in this there is a no guarantee that all nodes have the same data at any time, and there are many different implementations. So the most widely achieved is the ultimate consistency. So this is so-called final consistency, mean that the same data on any node is the same at any time, but as a time passes, the same data on a different nodes always change in the direction of the coverages. So it is also be simply understood that after a period of a time, the data between nodes will eventually reach as the consistent state. So it allows the distinct views of the database state to see a different and unmatched updates in the database state. So Now, casual consistency, eventual consistency is the weaker level of the consistency. The application developer must be explicitly in the knowledge of the replicated nature of the data items in the database. So the developer must adapt the replicate nature of the data in the database, which results in increasing in the complexity of the development as compared to the strong consistency. So now we will move to the types of the consistency. First one is the sequential consistency. So what is in the sequential consistency? We will see that the most important condition which forms the basic from the definition of a sequential consistency is that every write operation is ordered throughout the database system. Each thread being executed must visualize and use the specific order of the write operation set and accessed globally, irrespective of the fact that the which thread executed the operation and which data items were modified by a thread. So, however, note that it doesn't always necessary to hold true that the specified global ordering is the same as the real-time sequence of the execution of the each operation. So, there may exist and any ordering of the write operation as long as the specified ordering is agreed upon by and is followed by all the threads. So the only restriction is the specified as that the writes and reads are originating from the standard data thread of the execution must not be recorded. So here is the table of the data, and here we should take a note that the x and y in read and write execution are starting from the 0. So in T1 process, write x is pointed to the 100, and T2 process, write y is equal to the 200. In T3 process, read y is equal to 200, read x is equal to 0, and read x is equal to 100. And in T4, Ry is equal to 200 and Rs is equal to 100. So we will see what is the schedule S1. So S1 follows the sequential consistency and casual consistency, but does not adhere to the conditions specified for the linear consistency and strict consistency. So observe that the thread T3 and T4 follow the fact that the B has been updated before A. Eventually, through by thread T1 and T2, we can observe that the B was updated after A. As specified above, it is not necessary to follow real-time ordering for the creating global ordering. Hence, the schedule will stop. Hence, the schedule is still considered sequentially consistent because all threads are in the agreement for a certain order of a write operation for S1. So we will see thread T1, T2, T3, T4 as I explained above. So now we will see schedule S2. What is basically of what schedule S2 is? So S2 follows only casual consistency and does not adhere to the conditions specified for the sequential consistency, linear consistency or strict consistency. So S2 does not adhere to the rules specified by the definition of a sequential consistency because T4 does not follow the global ordering followed by the T3S. By T3, write or Y has been put prior to write of a X. So unitary to T3 and T4 reads an update to X earlier than the update for a Y. So the schedule violates the sequential consistency as all the threads do not mutually agree on the specific ordering of the write operation. So note that the consistency level, as we discuss next, exit as the existence of the sequential consistency time constraints are specified on the all write operations. So what is strict consistency? Strict consistency is the highest level of the consistency and hence it is the strongest consistency. It requires the write operation to be ordered on the basis of the real-time sequence to occurrence of each write operation. So the rule for the strictly consistent schedule specified that an earlier write operation must be seen before a later write operation Also, every read operation must read the value of the most recent write in a real-time order, irrespective of the which thread of the execution initiate that write. So, it is not feasible to implement a strict consistency at real-time distributed system, as it is impossible to have a global agreement for a precise time, and hence the order of the execution for a vast distributed data sets. So here is the table of the strict consistency. As we see here, the thread T1, T2, T3 and T4, same as we seen above. So now what is schedule S3? Why it's follow the strict consistency. S3 follows the sequential consistency, strict consistency, atomic consistency and casual consistency. Also note that the S1 and S2 are not strictly consistent. So S1 and S2 do not follow the strict consistency because all of them have either read of x is equal to 0, as we say r x is equal to 0, or read of y is equal to 0, as we say r y is equal to 0. After that, the value of x and y has been updated to the new value. S3 is a strictly consistent because all the read operations are reflective of the most recent write operation for each variable. So now we will move to the atomic consistency, also known as the linear consistency. So what is the atomic consistency? A schedule, if follows the condition for an atomic consistency or a linear consistency, is said to be a linearizable schedule. So linearizable schedule we will see into the next video. So what is the linearizable schedule? I will give to the lecture on the next video. The highest level of consistency that can be used for a practically for a distributed database system is a linear consistency. It also known as the atomic consistency, as used in the context of the CAP theorem. And also CAP theorem we will discuss in the next video. Atomic consistency does not specify any constraints on operation that occur with the overlapping start and end time stamps. There exists an ordering constraints only for operations for which time stamps for the given operation do not overlap, and hence in such cases it follows that the earlier write has to be seen before the later write. So here is the threads of the atomic consistency. So now what is schedule S4? So schedule S4 follows the atomic consistency, and hence S4 is the linearizable. Moreover, S4 follows the sequential consistency as well as the casual consistency. Note that the S4 is not a strictly consistent. Why? The schedule S4 does not follow strictly consistency because the read of a x by T3 is initialized a bit after the write of a x by T1, but the output for Rx is 0. Nonetheless, the schedule is linearizable because this read of a x by T3 and write of a x by T1 overlap in a time, and therefore linearizability does not require the read of the x by T3 to present the result of the write of a x by T1. We will see that in the form of a thread later on. While strict consistency and atomic consistency is stronger than the sequential consistency, it must be noted that the sequential consistency itself a very high level of a consistency, and there exists a weaker level of the consistency below it. So what is casual consistency? So it is the most popular and very useful consistency level that is below sequential consistency. In the sequential consistency, all write operations were bound to globally ordered irrespective of the fact whether they were related to each other or not. Casual consistency does not define and holds constraint on the unrelated write operations. If a particular thread executes a read of a data item as Rx and then write the same for a different data item like Ry, so the casual consistency assumes that the subsequent write may have been caused by the read. Therefore, the global ordering specified for the X and Y is as all thread, while execution must be observed at the right of a Y after the right of a X. So here is the thread of the casual consistency. So we will see the clearly difference in the thread 4. Ry is equal to 20, Rx is equal to 100. So now what is the schedule S5? So here for the S5, sequential consistency is violated. The schedule, however, follows the casual consistency. Also observe that the event to S2, its refer a sequential consistency does not follow sequential consistency. It does not follow casual consistency because the order of X and Y is not restricted by the any transaction. So here is the thread T1, T2, T3 and T4. Here in the T1 thread, write X is equal to 100, read X is equal to 100, write Y is equal to 200. In T3, read X is equal to 100, read Y is equal to 0 and read Y is equal to 200. We will see that here read Y and read Y. First read Y is the 0. In the same process, they will add read Y as the 200. In T4, read Y is equal to 200 and read X is equal to 0. So, what is schedule S3? The schedule S6 does not follow any among us the consistency being the discussed so far. So, this schedule is eventually consistent and eventual consistency is the weakest consistency. We will see what is the eventual consistency. In eventual consistency, it is the weakest level of the consistency. The only assurance offered here is that if there are no write operations for a specified period of a time, the thread will have to eventually agree on the value updated by the latest write operation. So, and hence eventually all the copies of the specified database will reflect the same value for a data